Okay, so let us now go back to our discussion of time varying interest rates. So recall that we had studied before that you might have long-term bonds which are offering different interest rates compared to short-term bonds. And we also discussed a way in which we can compare actually the interest rates offered by different bonds over different maturities along a dimension that is common to the different things that we are looking at, right? So this was the discussion of the annualized rates of interest that we had, which provided a way to compare rates of return over different time horizons. So let us now actually explore a very important economic kind of feature, which is this yield curve. Okay. This will also allow us to recap some of these concepts such as annualized rates of return. What is the relationship of that with the rate of return holding, and so 1 year interest rate and so on, right? Okay. So first, what is the yield curve? So the yield curve actually shows the annualized interest rate as a function of the bond maturity, right? So remember that the bond maturity tells us like the last date at which the bond payment is due, okay? And annualized interest rates, as we discussed, is a way of standardizing the interest rates that you have, okay? So this yield curve is also referred to sometimes as the term structure of interest rates or the term structure. So these are terms that you might come across in your reading of financial press and so on, right? And basically, it is a graphical representation which has the time to maturity on the x-axis and the annualized interest rates on the y-axis. So let's take a look at a particular scenario. So this is the yield curve for a particular date. So this is the one for the US government bond on December 31, 2021, right? So you can have the yield curve for different bonds. So it can be for the US government bond, it can be for Indian government bond, for British government bonds. It can be for different corporate bonds as well, right? So there's nothing specific about this. It's just that we are going to be using this for our illustration purposes, right? So remember, we said that on the x-axis, you are going to have time to maturity. So this is what you have here in terms of measured in months. And on the y-axis, you are going to have the annualized rate R in percentage times, right? So let us note some features of this. So we can see that it's upward rising, right? For quite some time, and then it's kind of like decreasing. And the other thing to note is that it's not actually linearly increasing or decreasing, right? So you have kind of like a part where the rate of actually change is also kind of like different. And here we have listed some of these numbers of this curve here because we are going to be using that for illustrating and doing some calculations, right? So for example, if you have a 1 month maturity bond coming up, so the yield curve would say that here the yield to maturity in percentage terms is 0.06. So be careful here. It's not just 0.06. This is 0.06%, right? And for 2 months, it's 0.05%. For 3 months, it's 0.06%. For 6 months, it's 0.19%. For 1 year, as per this curve, it's 0.39 percent. For 2 years, it's 0.73%, and so on. That is how you read it. And the other thing to keep in mind is this is the annualized rate, right? We'll soon see the significance of what that means for our calculations. Okay, so let's do a set of exercises to understand how one works with these curves. This will also help us to actually review some of the things that we had studied before in terms of annualized rates and so on, right? So in the exercise that we are going to do, we're going to actually rely on these numbers. So keep these numbers in hand and see how it works. Okay. All right. So the first question is that suppose you are going to buy a 3 month bond. Okay. And how much would 100 unit of investment turn into after this 3 months? Okay. So we need to look at what is the 3 month bonds annualized rate. So that's actually 0.06%, right? So now we are going to buy this and we want to figure out how much is this going to translate into after 3 months. So 1 unit of investment here would have actually translated into 1 plus 0.06%. So this is the annualized rate for the 3 months that we had in this kind of like table, remember? And then you need to take the power to the power 1 by 4, right? Now, one question is, why are you taking it to the power 1 by 4? Remember, this is the annualized rate, right? This is telling us that what would have been the total kind of like thing after 1 year. But here, because you are only using it for 3 months, so 3 months is 1/4 of a year, right? And so you need to take to the power 1 by 4, right? Now, this was for 1 unit of money. If you have 100 units of money, you need to multiply it by 100 in front. And this is our final answer, right? Okay, now you need kind of like to use the calculator to come up with these expressions. Again, be careful that this is 0.06% and not just 0.06. So this addition is not 1.06, right? It's 1.0006. And if you now do the calculation carefully, you end up getting that this is going to become 100.015 approximately, right? So that's how you do this answer. Okay. Now, suppose instead of doing a 3-year bond, you want to do a 30-year bond. Okay. So how much would 100 unit of investment turn into 30 years if you are investing it in the 30-year bond? So again, the first thing that you do is you go back and you look up the number for the 30 years rate. So you can see that the yield to maturity here is 1.90%. And again, this is annualized. So therefore, 1 unit of money would have translated into 1 plus 1.90% to the power 30, right? Why are we doing to the power 30? Because the 1.90% is the annualized rate. So if you are looking at what happens after kind of like 30, so this should actually be after 30 years. So after 30 years, then you have to actually take to the power of 30. Okay. So if you take to the power 30, this is one rupee. And so therefore, if you have got 100 amount of money that you are putting in, so you need to multiply it by 100. And so therefore, this is going to become 175.884, right? Again, this is a typo, so that will be corrected in the slides that you see later on. Okay, so those are two calculations. We can ask other questions. So for instance, what is the yield for a 4-year bond? If you notice here, we have not given the numbers for the 4-year bond, although you could actually read it maybe from here. So 4-year bond would be the one corresponding to 48 months. But the other way of doing it is that you can actually use the 3-year and 5-year data to kind of come up with a number. So basically 4 years lies at the middle of this 3-year and 5-year. So one rough approximation is that you could just have actually just look at the average of this 3-year rate and the 5-year rate's annualized rate, right? So you end up getting that would be approximately 1.12%. Again, the annualized rate. Now, this is not an exact number. And the reason is because this graph that you see here is clearly not linear, right? If it was linear, then we could have just looked at, okay, you have got 2 points. The midpoint is also going to lie on the line, right? But because we know that the curve is not linear, then we should keep in mind that this is actually an approximation, right? If you want to come up with the precise number, you should actually go and actually examine this figure, right? Okay, so that's another way in which you can use the information that is presented. Let's do a few more exercises. These are a bit more involved. So one thing to keep in mind is that in the discussion with the numbers that are coming up, we are going to be implicitly assuming that these are basically zero bonds, which means that these are bonds without any interim coupon payments. Okay. So let's look at the first question. Suppose that you want to invest 1 lakh units in 2-year bonds on December 31, 2021, right? What would this return on December 31, 2023? Now, what's the significance of this December 31, 2021? This is exactly the information that we have in this graph and this table below, right? The other part is that we want to invest this amount of money into your bonds. We want to know what is this going to return 2 years later, right? Now, is it as simple as kind of like just using this annualized rate that you have here? Not directly, right? So we have to do an intermediate step, which is that we have to figure out a way to convert basically this into the 2-year actually holding rate. So let's understand how do you do that. So the 2-year holding rate, let's denote that by R02. So this is basically saying what's the rate of return that you get if you have 1 unit of money today and you are kind of investing it now and getting the money back after 2 years. So how do you do it? using the information. So the relationship between the 2-year holding rate and the annualized rates that the 2-year annualized rates that you have is given by this expression. So 1 plus R02, where R02 is the 2-year holding rate, that's going to be equal to 1 plus R2 bar to the power 2, right? Why are we doing to the power 2? Because remember, this is the annualized rate, right? So we need to multiply, this is the first year's rate, and then this is the second year's rate, right? And so therefore, from there, we end up getting this expression, right? Now, you have got information that this is 0.73%. So if you put in R2 bar as 0.73%, so this becomes 1 plus R2 is 1.0073. And similarly for this number here, right? And you can use that to calculate RO2, right? So RO2 is basically, you end up getting 1.465%, right? So this 1 lakh units is going to turn into 1 lakh multiplied by 1 plus 1.1465%, or which is approximately equal to 101465. So notice one important thing. When you have the actual 2-year holding rate, you do not have to take to the power 2, right? Then you would get a wrong answer. So you can just use that directly as the standard way in which you use interest rate, right? And get the answer. The other thing to note is that, you need not have converted this into the 2-year holding rate, right? The other way of doing this exercise would have been you use the annualized rate in the way we have discussed before, right? So here 1 lakh multiplied by 1 plus 0.0073 to the power 2 would have also given you the answer. But we did it in this way as well to kind of like show you a different way of doing it, and also show you how you can actually use the information on the annualized rate and use that to come up with the holding rates for different maturities, right? So that's another useful thing to keep in mind. Okay. What if you invest this 1 lakh units in 30-year bonds? Again, you can do it in these two different ways. You could have actually used the annualized rate information directly in order to calculate, but you could also convert it into a 30-year holding rate of return. So if you want to do that, let's call that holding rate of return as R030. So you need to have 1 plus the annualized rate corresponding to 30 years. So that's the 1.90%. Okay. So that means this is basically 1.0190. Then you take to the power 30, because this is basically your calculating 30-year return, right? And then you subtract 1, so that gives you 1.759, right? Minus 1, so 75.9%, right? So this 1 lakh units is going to basically become 1 lakh into 1 plus 75.9%, or approximately equal to 175,884, right? So this is how you do the calculation. Notice that this is actually the same thing that we did here before, but there we were using directly the annualized rates. Here we are actually first checking how you convert it into a kind of like a holding rate of return, and then use that to do the calculation. Okay, let's look at a bit more sophisticated question. So based on this yield curve, what's the 1-year interest rate from December 2022 to December 2023? Okay, notice that this information is not directly present either in the graph here or in the numbers that are here, right? But the important point to note is that you can use this information that's present on this slide to actually come up with this number that you care about, right? Now, before we look into the calculation, why do we care about a number like this? So imagine that basically what you want to do is that you want to say that, okay, we want to plan ahead so that 1 year later from now, where now is, let's say, December 2021, we want to say that, okay, 1 year later from now, we want to go in and issue a bond that is going to pay out 1 more year later, right? So what should be the interest rate for the bond that we would actually have for that bond? And so here the interest rate would correspond to this R12. So this is basically the interest rate for an instrument that begins in 1 year and ends in 2 years, right? So this is the 1 year interest rate, but notice not beginning today, but beginning 1 year from now, right? So these are what are known as examples of forward interest rate or the forward rate. And one can use the information that is present in the yield curve to actually calculate these things, right? So how do you do that? Well, let's look at the information that we have. So we have the information about 1 year annualized rate. So if you go back, this is the 0.39%. for the 1 year maturity period, right? So this is also the same as the R01 that you actually have, right? And you also had the information in the same graph or the table for the 2 year annualized rate, and this was the 0.73%, right? So from here, you could actually calculate what's the 2 year holding rate of return. This is the exercise that we have been doing for the past couple of questions. How do you calculate it? So the 2 year holding rate of return, R02, is 1 plus R bar 2 square. So where R bar 2 is the annualized return for this 2 year bond, right? Minus 1. This is the same calculation that we had done before. And so therefore R02 we know ends up as 1.465%, right? Now, what's the relationship between this 2 year holding return and the 1 year that we are actually interested in calculating? Well, we have this 1 plus R02, where this R02 is exactly what we calculated before. This is saying that, okay, if you have a bond that is going to pay out in 2 years, what's going to be the return? The other way of thinking about it is that, in principle, this should actually give us the same return if we had just invested money 1 year for today into a 1 year bond, and then again kind of like invest it again in another 1 year bond from 1 year from the next year, right? So this relationship hold, otherwise there would be arbitrage opportunities, right? So based on this, we have already have a number for this 1.465% for this R02, and we also have the R01, remember, from before. So this is the 0.39%. So now we basically can solve this equation for the R12, right? And if we do that, then we end up getting that the forward rate R12 is approximately equal to 1.07%, right? And this is the same procedure actually you can follow for doing a bit more complicated calculations. So suppose that we are interested in calculating R23, we can actually extend this. So for example, we would first need to calculate R03 using the information that is present here, right? So then this would be the 1 plus 0.97% to the power 3 minus 1 will give us the R03. And then based on that, what we would do is like 1 plus R03 is equal to 1 plus R01 multiplied by 1 plus R12 multiplied by R plus 23, right? We already have information about R01 and R12. So we can then use that to do these calculations, right? So so you will have basically kind of like see that there are this different kind of like ways of quoting the interest rate that comes up, right? So you have now actually seen 3 of them. So you have the holding rates of return, which is in terms of time 0. Suppose you are thinking of, okay, I want to kind of like have a bond which is going to pay out in period T. So if I invest 1 unit of money, how much is that going to kind of like translate? So that's what you get from the holding rates of return. You have the annualized rates of return, which is the way of standardizing the different returns that you are getting across different maturities that we have seen before. And you have also this individual rates of return, annual rates of return that we have seen, right? So all these examples that we had, R12, R23, and so on, this would be examples of this, right? So we have these different ways of kind of like working with these things. And the reason why we have it is because we want to kind of like understand these different fixed income investments such as bonds that we see, which may have different maturities, right? Some may be very short term, some may be long term, or they may have even different starting dates, right? So you may have a 1 year bond which is issued today and which pays out next year. Or you might have a 1 year bond which is going to be, let's say, issued 5 years down the line and is going to pay out in year 6, right? So you need a way of kind of like moving back and forth between these different things, because you might want to compare, for example, what is the kind of like the rate corresponding to the government bond, and how does the rate that corresponding to the rate issued by a particular corporate, let's say, right? So all of these things, in order to study these are actually kind of like useful. And so you need to know how to kind of like go back and forth between these different measures and how to use these to do the sort of calculations that we have been seeing so far.